In this video, we're going to look at how to calculate critical regions for a geometric distribution. So let's take an example. Aisha wishes to test if a 5-sided spinner numbered 1 to 5 is fair. She spins the spinner and counts the number of trials until she gets the spinner to show the number 1. So the probability until something occurs for the first time is what's known as a geometric distribution, which is very different from a binomial distribution, as I alluded to in my previous video. So using a 5% level of significance, find the critical region for a one-tailed test of the hypotheses that the probability of getting the number 1 on a single spin is less than 1/5. And we need to calculate the actual level of significance for part B respectively. So let's go ahead and define our random variable. So let's do that. So let the random variable x be the number of spins until getting number 1. So let's follow the geometric distribution. If the hypothesized probability is correct, then P will be 1/5. So let's set up our null and alternative hypothesis respectively. H0, P is equal to 1/5. Go back to the claim now for the alternative hypothesis. H1, that we go back to the question, let's read it. So it's less than 1/5. So that implies that P must be less than 1/5. Making it clear to the examiner. One-tailed test. So it's a one-tailed test, and we can say that alpha, the level of significance, is 5%. We ought to really say it's a one-tailed lower test, so I'm going to write that in. So to be pedantic here, so one-tail lower test. So what we want is a critical region, but remember that we stated earlier in previous videos that as P increases, or we can say decreases as well, doesn't make a difference. So we could say as P increases, the mean of the geometric distribution decreases, or vice versa. If P decreases, the mean of the geometric distribution increases. So we want the probability that x is greater than or equal to some critical value, call it C1, okay, and that must be strictly less than 0.05. So now, because don't forget that the alternative hypothesis is that P is less than 1/5. So since P decreases and the mean of the geometric distribution increases, the probability of the observed value must be greater than or equal to the critical value here. So what we can do, we can use our formulas from before. So we know that the probability that x is greater than or equal to x is 1 minus P, x minus 1. So because x refers to C1 in our case, it's going to be the following: 1 minus, I'm going to write P here, Okay. So to the power of c minus 1, because our little x is c1. So in our case, it's c1, sorry. c1 minus 1. And that must be strictly less than 0.05. Now, our probability is a fifth. So we say 1 minus a fifth raised to the power c1 minus 1 is strictly less than 0.05. That's 4/5 to the power c1 minus 1 is strictly less than 0.05. So then what we could do is solve this equation by using the natural log. So the natural log of 4/5 to the power c1 minus 1 is strictly less than the natural log of 0.05. Using the laws of logs now, c1 minus 1 comes down. Then we get ln 4/5 is now, here's the important parts here, is strictly less than ln 0.05. But because ln 4/5 is a negative value, when we divide by a negative value, the sign of the inequality sign will change. So c1 minus 1 will now become greater than ln 0.05 over ln 4/5. Use our calculator, write the full value out. So I'm going to say it's 1 plus this. So say ln 0.05 over. So then on the denominator here, we have ln 4/5. Then we can say c1 is greater than, I'm just going to get my calculator to type it in, 1 plus ln 0.05 over ln 4/5. I'm using the Casio CG50, by the way, so it's a great calculator. So we get 14. I normally write the full calculator display out. 14.2513488. We need to be strictly greater than that value. So therefore, C1, you could write C as well. It doesn't make any difference. It's 15. So we can say, therefore, CR is a critical region. It's actually known as a rejection region, but at A-level we call it a critical region. In more formal statistical courses, it is denoted as a rejection region. So the critical region is as follows: is x is greater than or equal to 15. Now part B says in the question to calculate the actual level of significance. So that's the probability of x being greater than or equal to 15. In chapter 8 of this course, known as quality of tests, you will learn to calculate something called the probability of a type 1 error, and that's the probability of rejecting the null hypothesis when it's actually true. So that's an example of what we do here. It's called the probability of a type 1 error. So we can use our formula. You can also just calculate that directly from the calculator using a geometric distribution, but just for some people who may not have that the CG50, they can learn how to do it. That's 1 minus the probability of x raised to the power minus 1. So in our case, we can do that. So it's 1 minus a fifth raised to the power of 14. So that's as 4/5 raised to the power of 14. I'll do that here. So from my calculator, I will get the following value. I will get 0.0 0. Again, I'll write the full value out here. 0.0439804651. People say, so why are you writing the full value out? You can just round it straight to 4 decimal places. Well, I say sometimes in subsequent calculations it may be required and you can only round at the end, so it's always good practice to have the full value on your paper just in case it may be required later. So that works out to be 0.0440, correct, to 4 decimal places. So that's our first example there. Now you're going to try a question similar to that. Here's a question for you to try. You can pause the video, and when you're done, I will go through my work solution. Okay, welcome back. So let's read the question first of all. Dot is a professional darts player. She claims that the probability that she will hit the bullseye with a single dart is 1/3. Her arch rival Sharon claims that Dot is exaggerating her ability to hit the bullseye. To test this claim, Dot throws darts until she hits a bullseye. Find the critical region at the 5% level of significance for the number of darts thrown by Dot in order to accept Sharon's claim, for 6 marks here. So we're going to do, as always, define our random variable. So we do it as follows. We're going to say let x be the random variable that represents the number of darts Dot throws until she hits a bullseye. We said that's the key characteristic of a geometric distribution. It's the first time something occurs. So until she hits a bullseye. Then we can set up our hypothesis. So we'll set our model first. X follows the geometric distribution, P being 1/3. No hypothesis, P is equal to 1/3. The alternative is P. If she's overstating her ability, it's actually less than what she claims. So it's P is less than 1/3. We state it's a one-tailed lower test. Where alpha is 0.05. So now what we can do is, as we always write, we say as P decreases, the mean of the geometric distribution P increases. So we want the probability that X is greater than or equal to the observed value. So in our case, X is greater than or equal to some critical value that we don't know. I previously called it C1. You can call it C as well. It doesn't make a difference. It's just that from the Poisson distribution and from regular interval, the binomial, we had 2 tails of a critical region, so we normally call it C1, C2. But in this case, we can of course call it C for the critical value. So we want this to be strictly less than 0.05. And then we can again use the formula we had before. 1 minus P, the probability of C minus 1 is strictly less than 0.05. Our probability is 1/3, so 1 minus 1/3 to the power of C minus 1, strictly less than 0.05. So we get 2/3 C minus 1 is less than 0.05. So we can say ln 2/3 raised power c minus 1 is strictly less than the ln of 0.05. From the logs of logs, bring this down. As we said in the example, that ln of 2/3 example is a negative value, so the inequality sign will change. So c minus 1 is going to be strictly greater than ln 0.05 over ln 2/3. So use a calculator now to obtain the full value. So it's going to be c is 1 plus this value. Just type it into our calculator, write the full display out. So So 8.388384879. So we can say from here that C is greater than 8.388 and so on. So C must be 9. Therefore, the critical region, CR. So therefore, CR is X is greater than or equal to 9. And the actual level of significance, or also known as the probability of a type 1 error, is X is greater than or equal to 9, which is, we said, is 1 minus the probability power X minus 1, so 9 minus 1 there. So that's going to be 2/3 all raised to the power of 8. Again, I'm going to write the true value out and then round to 4 decimal places respectively. So that's going to give me 0.039 0184421 231, sorry. So that works out to be 0.0390, correct to 4 decimal places. Okay, here's the last example on critical regions. So in a particular city, a lobster card is used as a method of payment on trains. The company that administers the card claims that 1 in 1,000 cards will be rejected by the card reader at the train station. A station manager feels the company is understating the proportion of cards rejected by the card reader and decides to carry out the test. When he comes on shift at 5 a.m, he counts the number of passengers who pass through until he notes a passenger who has a lobster card rejected. Using a 5% level of significance, find the critical region for a one-tailed test of the hypothesis that the proportion of lobster cards rejected by the card reader is greater than 1 in 1,000. So let's start off by defining the random variable. So we say let X be the random variable representing the number of cards read by the reader until 1 is rejected. So until 1 is rejected. So we can say that x follows the geometric distribution of 1 divided by 1000, which is 0.001, because it's the first time until 1 card is rejected, so therefore it's a geometric distribution model. So H0 P is 0.01.
You'll need to unlock.
Then we have the following H1 that we're going to say it's greater than 0, case that as P increases, the mean of the geometric distribution decreases. Therefore, what we want is the probability of our observed value to be less than or equal to some critical value C, and this must be less than or equal to, or sorry, strictly less than 0.05. It's got to be strictly less than 0.05, otherwise we wouldn't be able to reject the null hypothesis. So it has to be strictly less than 0.05. So now that we've got that, we can use our formulas to say if it's less than, what do we do? So if it's less than, it's 1 minus p power of x. So in our case, it's 1 minus p. In our case, the power of c is strictly less than 0.05. In our case, it's 1 minus 0.001 raised to the power of c is strictly less than 0.05. So in our case, 1 minus 0.999 c is strictly less than 0.05. So we can say the following here, that 1 minus 0.05 is strictly less than 0.999 raised to the power of c. So we're saying 0.95 is less than 0.999 raised to the power of c. In other words, it's the same thing as saying 0.999 raised to the power of c is strictly greater than 0.95. Then we do ln 0.9999c is strictly greater than ln 0.95. Then c, bring the c down with lots of logs, is strictly greater than ln 0.95, and then ln 0.9999 is a negative number, so the inequality sign is now going to change. So by doing that here, let's change the inequality sign. ln 0.95 over ln 0.999. Write the true value out with our calculator, and then we can round. So get my CD50 here. We're just going to do as follows. We're just going to do ln 0.95 over ln 0.9999, and that gives you 51.26764,346, which is the same thing as 51. So in other words, our critical region is CR is x is strictly less than or equal to strictly less than or equal to 51. Improve the clarity of my handwriting there. and to find the actual level of significance, it's the probability that x is less than 51. What I alluded to was a type. This is an example of what we call a type 1 error, when you reject the null hypothesis is actually true. So we can do that. So we can say it's 1 minus 0.999 raised to the power 51. Okay, and let's use the true value and then round for dp. So 1 minus 0.999. Again, I'm just using the CG50 here. So let's write the true value out. So we get 0.049. 455 743. And into 4 decimal places, that works out to be 0.0497. So here's a question for you to try. You can pause the video. When you're done, I will go through my work solution. Here we're going to be careful that alpha is actually 10%, the significance level. So we state the usual thing as we always do. As p increases, the mean of the geometric distribution p decreases. So you can effectively say that we're interested in working out the probability that x is less than or equal to c, strictly less than 0.10, not 0.05, but this we know is 1 minus p raised to the power of c is strictly less than 0.10. So 1 minus 0.10 is strictly less than 1 minus 0.05 in brackets raised to the power of c. 0.90 is less than 0.95 raised to the power of c. So now what we're going to get is ln 0.95 raised to the power of c is greater than ln 0.90. Bring c down, so c ln 0.95 is strictly greater than ln 0.90. And then here we can divide them. Don't forget we divided by negative, so the inequality sign will change. So essentially we divide by ln 0.95. So now using the CG50, ln 0.90 over ln 0.95 gives me 2.054079718. So bring the power down, we get ln 0.95 greater than ln 0.90. Divide by negative, we get the inequality sign changes to ln 0.90 divided by ln 0.95. So c is less than 2.05, so we can say c is strictly going to be equal to 2. So we can say, therefore, the critical region is x is less than or equal to 2. So the actual level of significance is this probability that x is less than 2. Those of you that have the CG50 like I do, you can just use the geometric distribution, get the answer straight away. But I'm just going to use the formula here for those who may not have the CG50. Okay, so, and don't forget, here we're going to put squared here, and that's just going to be 0.0972 5. And we're done.